Now, the big difference between Alzheimer's disease and Huntington's disease is that one is monogenic, Huntington's disease, one gene, and the other is multigenic. There are a lot of genes which will confer an increased risk. And again, it's difficult to know how to get at that. But we've done another proof of principle study in another multigenic disorder, much less well understood, and that's schizophrenia. I have a colleague here at UCL, Hugh Gerling, who's a geneticist, and he's been really hunting for genes that will confer increased susceptibility. And there is one such gene that he's been particularly studying, which gives you an increased risk of about 6 or 7% of developing schizophrenia if you have it. So we're able to compare the brains of normal people with those with schizophrenia, independent of whether they have the susceptibility gene or not. So let me show you on the brain. Amongst other areas where there's local atrophy in schizophrenics, these parts of the cortex, the temporal poles, and also this underpart of what's the frontal lobe, we call this the orbitofrontal lobe because it sits immediately above the orbits of the eyes. There's focal atrophy there. There are other sites, but let's just think about those two sites. Now, when we come to look at the interaction, what we find is that in schizophrenics with the susceptibility gene, that atrophy is profound. In schizophrenics without the susceptibility gene, it's this atrophy that is profound. So what we're doing is showing that using these techniques we can apportion the biological part of the susceptibility, if you like, through both the symptoms and their brain basis. So we think we've got an entree there into beginning to examine these multigenic disorders.